So here's our second video on quadratics, and I've taken a screenshot of the first video, the first slide, just to remind you of a few things. So I want you to remember quadratics are things that have x squared. In the last video, we talked about this vertex form and doing transformations to graph quadratics, which is pretty easy and comes up with a pretty nice graph. And today we're going to talk about what to do with this standard form. Remember last time when we graphed, we found the vertex. We didn't really talk about it, but we can also find the axis of symmetry. But the things that we haven't been able to find so far, unless we happen upon them when we're graphing, are the y-intercept and the solutions or zeros. So that's really what I want to focus on today, is how to find those other parts of a quadratic. All right, so when we talk about standard form, a few things should come to mind. First of all, this a is the same a that it was before, and it is I guess I should write this right, it is a vertical multiplier of the pattern, which is just that standard 1, 3, 5, 7 that we talked about. All right, and then our C is going to be our y-intercept here. And then the whole idea of standard form, the best thing that it's used for is really for solving quadratics. And we're going to dive into these a little bit more later, but we still want to talk about how to graph quadratics with standard form and find some of the important pieces of information. So like I said, factoring we'll talk about more in depth at a later time. The quadratic formula we are going to spend some more time on later, but I do want to remind you of what the quadratic formula is, because I think that you're going to remember this from Algebra 1. And that is that x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And hopefully you're thinking about a song when you see that. But the part that I wanted to point out to you is that we can actually find some other things out about this quadratic. I mean, right now, with just the pattern and the y-intercept, I can't really get much of a picture of what the parabola looks like. But if I use the quadratic formula, or at least part of it, I can get some more information. And the part that I like the most is this part right here, outside of the square root. And the reason I like it is because this part of the quadratic formula gives me this axis of symmetry, which is another part that we haven't talked about yet. So we're going to use these pieces of information to graph parabolas. So let's look at how we do that. All right, so in the last form, in vertex form, obviously the first thing we wanted to name was the vertex. And that is still going to be an important piece of information. What I like to do first is go ahead and name all of the information that I see right away. So for instance, I see this -5, and I know that it's the y-intercept. And then I know this -2 is going to be a vertical stretch of 2, and the negative is going to be a reflection. So I'm going to keep those things in mind. And then I need to go ahead and find the axis of symmetry, which will help me find that vertex, because we said that really is the critical point. That's the one we need to know first. So my formula for for axis of symmetry is that x equals negative b over 2a. And I know that this is a, b, and c, so that's going to give me negative 8 over 2 times negative 2. And when I work that out, that gives me the axis of symmetry of positive 2. Now, that's the x value for the axis of symmetry. So if I go ahead and draw that on my graph rather, the x value, that means I have this axis of symmetry line at 2. Now, I know the vertex has got to be on that line because the parabola is equivalent or symmetrical on each side. So I'm going to take that value of x equals 2 and plug it back in to the x parts of the original function. So if I do that, that's going to give me, solving for the vertex now, that's going to give me negative 2 times 2 squared plus 8 times 2 minus 5. All right, this is negative, well, if I work this out order of operations, 2 times 2 is 4 times negative 2 is negative 8 plus 16 minus 5. If I simplify that, that gives me 8 minus 5, which is 3. So that tells me my vertex is 2, 3. All right, so I'm going to go ahead and plot that, 2, 3. Well, hopefully I'll plot it correctly. And now I can go ahead and apply that pattern and the y-intercept that I know that I should be getting. So if I apply the pattern here, vertical stretch of 2 means I'm going to be going, and it's down actually, right? So like down 2, down 6, down 10, because I'm multiplying the vertical and still over 1. So I'm going to go down 2 over 1, down 6, 3, 4, 5, 6 over 1, and then the same thing on the other side. And notice that that kind of checks itself because I just said at the very beginning that the y-intercept should be -5, and indeed, that does end up crossing the y-axis at -5. So that's how we're going to graph in standard form. You can still name the domain and range like we have done before now that we have the graph. The domain here is going to be all real numbers still, -infinity to positive infinity. And then the range is going to be -infinity up to 3 included because that's the highest y value. Now, the piece that we're going to add in next, which is not going to be in this lesson but in the future lessons, is how to actually find these intercepts. Because as you can tell, this is not actually crossing in a very good place on the x-axis. Like I know that one of these roots is somewhere in between 3 and 4 if I zoom in, and the other root is somewhere in between 0 and 1, but I don't really know where. So the only other thing that you really need for your notes today is maybe to add, or at least for this example, is just to have explanations on exactly the steps that I'm doing here so you remember how to do this when we practice in class tomorrow. So the last thing I want to talk to you about in this video is how to convert between standard form and vertex form, because there are times if we're talking about transformations that it makes more sense for it to be in vertex form. So the first thing what we want to do, this is called completing the square. I don't know if you remember doing this in Algebra 1. And the first thing I want to do is identify the information that is the same between vertex and standard form. And that's going to be this multiplier in the front. So I know that this 3 is going to still be in my answer. So like if I go ahead and write out just kind of an idea of what my answer is going to look like, I know that my answer is going to look something like y equals 3, parentheses squared, and there's going to be some numbers, right? X plus or minus something, and then plus or minus something on the outside. So our job is to figure out what are these numbers. So I know that 3 needs to be on the outside of parentheses, which means I'm going to have to divide it. So I'm going to go ahead and do that. And I'm really only going to divide the 3 out of these first 2 numbers. So when I do that, that's going to leave me with x squared minus 10x. And I'm going to put a plus blank. Okay, our job is to figure out that blank. And if you remember completing the square either from geometry when you did it with circles or from Algebra 1, we take half of this middle number, and that's going to give me 5. So in parentheses, I have x minus 5 squared. And then I need to square, notice that you're writing that squared, right? I need to square that number. So 5 squared is going to give me 25. Now, that gave me one step, one more number in my process. So I got the 3. Remember, I got this 3 in the front from the multiplier. I now know that this inside number should be minus 5. I did that when I divided by 3 and then took half. And the question is then what should that last number be? So remember, I'm changing that or filling this out to be 25, but really this whole thing has been multiplied by 3. So that number is not actually 25. That number is really 3 times 25, which is 75. So now the question is, how do I fix that to be equivalent to my original problem, right? I currently have 75 in this problem that I've made, but I need to fix it to be back to the 77. So to fix that, I'm going to add 2. So on the outside of my vertex form, it becomes plus 2. There is another way for me to kind of show you how to change this into vertex form, but honestly, I need you to know how to complete the square because we're going to do some things with that later on this semester. So if we need to talk about this example when we come back to class tomorrow, we can definitely do that.